Good morning, Americas. Good afternoon, Europe, Africa, Middle East. Good evening, Far East. Good night, Oceania. Thank you for being with us from around the globe. I'm Luc Ledoux. I work for Sidlines, an Ecolab company, the newly created animal health division of Ecolab, a worldwide leader in hygiene solutions. At Sidlines, an Ecolab company, an ounce of prevention is worth a pound of cure, and that is where health begins. Today we're here to talk about avian influenza, and I would like to start with a practical piece of information. You can type in questions at any time in the chat box. However, I would suggest to keep them from the end of the second presentation because maybe your questions will have been covered. We are honored today to host and to learn from Dr. Catherine Bertrand. Dr. Bertrand graduated in veterinary medicine from the Universitat Autònoma de Barcelona and obtained her PhD from the Centre de Recerca en Sanitat Animal. I hope, Dr. Bertrand, that the pronunciation of my Catalan was not too terrible. She did a lot of research on viral diseases of birds, evidently on avian influenza especially. She has worked on avian influenza transmission at the animal-human interface, and she worked at centers such as the World Animal Disease Institute, or the OIE, reference lab for avian influenza in Padova, Italy, at the Southeast Poultry Research Laboratory of the USDA, the United States Department of Agriculture, in Athens, Georgia, and at the National Veterinary School in Toulouse, France. She has published over 35 articles on the subject and given lectures all over the world. Dr. Katteri will give us an update on avian influenza, but first I would also like to introduce my colleague, Eline Kleijs. Hello, Eline.
Hello, Luc. Thank you. Hello, everyone.
Eline has a Master of Science in Chemistry, and she was born and raised on a poultry farm. Eline is our biosecurity expert at Sidlines, an Ecolab company, and she will explain us how practical biosecurity can help to prevent and control avian influenza. Dr. Bertrand, the virtual floor is yours now.
Thanks, Luc. Thanks for the introduction. I'm going to share my presentation. Please let me know if you can see it. Perfect. Okay, so as Luc said, I'm going to give a brief introduction to the disease, starting on basic concepts and then going into the current state of the disease in Europe. So to start off, just to say that influenza viruses are from Orthomyxoviridae family, and in particular, those that affect birds and mammals belong to type A influenza viruses. All influenza viruses have an RNA virus that on top of that has a segmented genome, as you can see in the figure below. And these two characteristics make these viruses very prone to constant evolution and constant mutations. The basic mechanisms for which influenza viruses evolve are, on the one hand, antigenic shift, which consists basically in the combination of different segments from different viruses that infect one cell, resulting in a new subtype of influenza viruses. And then the other mechanism is antigenic drift, or what is the gradual acquisition of mutations in the genome thanks to the RNA polymerase, which is prone to accumulate errors and that cannot correct these errors. So we can see that these viruses are very prone to constant evolution. The major antigenic sites and surface proteins are the hemagglutinin and the neuraminidase. So this is a basic scheme of the epidemiology of avian influenza viruses. As you can see in the center, we have wild waterfowl, which are considered the reservoirs for all influenza viruses. That here you can see that they go from hemagglutinin 1 to hemagglutinin 16. Basically, they can harbor many different combinations of hemagglutinins and neuraminidase. And typically, these viruses don't cause any clinical disease or mortality in these reservoirs. However, these birds can spill over avian influenza viruses to other hosts. As you can see in the figure, it can transmit to mammals, both domestic and wild mammals, and also domestic birds, which is the main topic of our conversation today. And how does this happen? As I said, wild waterfowl are the reservoirs for all avian influenza viruses that we will namely call them low pathogenic avian influenza viruses. But through exposure and adaptation, they can transmit these low path viruses to poultry, to gallinaceous species, which can be turkeys, chickens, etc. These low-path viruses typically cause mild clinical disease or asymptomatic disease in gallinaceous species, but if they continue to circulate in these domestic poultry, specifically H5 and H7 low-path viruses can accumulate certain mutations in the hemagglutinin gene, which turns them into high-path avian influenza viruses with as you know, devastating consequences for the poultry industry. Now, these highly adapted poultry viruses typically cannot go back and infect their reservoir species. However, we have a clear example of an exception to this rule, which is the Goose Guangdong lineage of high-path avian influenza viruses. This Goose Guangdong lineage, we saw that they were able to infect again the wild waterfowl reservoir species and circulate in these ducks, either domestic or wild, spread these viruses, and then transmit again into gallinaceous poultry. Now, there are different routes for which avian influenza viruses can go into a farm. First of all, the first introduction into a region or a country, as I said, is made through the contact with infected waterfowl, either direct contact with these birds or with contact with infected contaminated droppings. However, while this index case is normally with contact with this wild reservoir, the secondary cases or the lateral spread from farm to farm in a particular region happens mostly due to human interactions, human epidemiological contacts between farms, shared equipment, etc., which Eileen later will explain in detail. So just a brief summary of the clinical manifestations of avian influenza. We have two pathotypes, low pathogenic and high pathogenic. Low pathogenic, as I said, is typically symptomatic or can be a mild respiratory or digestive disease with no or low mortality, but it can affect egg production and egg quality. And in the context of a farm, due to other concomitant diseases or non-infectious factors like the stress, ammonia levels, etc., it can be exacerbated and it can cause some mortality. On the other hand, highly pathogenic avian influenza, which is only caused by H5 and H7 subtypes, is a fatal systemic disease that can cause up to 100% mortality. And as you can see here, we have a variety of gross lesions that go from necrotic pancreas, cyanotic wattles and combs, cyanotic legs, petechias in the muscles, etc. And it can also manifestate in different ways. You can have a sudden disease, sudden mortality with no clinical signs, or you can have a wide spectrum of clinical signs that go from respiratory to egg production to neurological signs. So going back into the situation that we have in Europe, just let me explain where these viruses come from. As I was saying, the Goose Guangdong lineage is the one that has caused many problems all over the globe. And these viruses originated in Southeast Asia in the late 1990s. And from there, as I said, they were able to go back and infect wild waterfowl. And by infecting this wild waterfowl through their migration routes, they were able to spread these high-path avian influenza viruses into different regions of the world and to different continents even. And while spreading into these different regions, they also diversified into different groups that are genetically different and that we name clades based on the genetics of the hemagglutinin gene. So one of the most recent clades to emerge is the clade 2344. It emerged in 2009 approximately, but we know that in winter of 2014, one of the migrations to the breeding sites of these waterfowl species brought with them these clade 2344 viruses, and through different migrations going back to the winter sites, they brought these high-path viruses into North America and also into Europe in the fall of 2014. In these two continents, these high-path viruses that we name Eurasian H5 and 8, which was the case in that time, they reassorted with local low-path viruses, both from the North America and from Europe, giving rise to reassorted H5 and X. And we call them H5 and X because by that time, we saw that clade 2344 viruses were no longer only H5 and 1 viruses, but they had an enormous plasticity in the potential of reassortment that allowed these viruses to reassort with different ends, resulting in the circulation of viruses of H5 and 8, H5 and 2, H5 and 1, etc. That's why we call them H5 and X. So since 2016-17, in Europe, we have seen different waves of epizootics every winter. As you can see in these summary maps, we had two very bad years, which were 16-17 and 2021. For some reason, 3 years in between were pretty mild. But as you know, this year is being one of the worst, if not the worst, and I'm going to go into more detail about this. So this is another way of representing the number of outbreaks with these H5 and X high-path viruses in Europe, starting with the epizootic of 2016-17 and going through the different years until the current year. As you can see, 16-17 and 2021 were very, very bad. But you can see that the current year has been also very bad. And as a matter of fact, this graph only includes the outbreaks until March. So we have 2 more months to add more outbreaks. So just to give you some more details about what the viruses circulating in Europe are, well, last year we had variety of subtypes circulating in wild birds, mainly H5N1, H5N5, and H5N8. Most poultry outbreaks were caused by the subtype H5N8. However, this year, we had a predominance of circulation of H5N1 in wild birds that has translated in dominance. Almost 100% of all outbreaks have been caused by H5N1 in poultry. If we look at the type of domestic bird that have been affected in these 2 years, we saw that at the beginning of the 2021 epizootic, most of the outbreaks in domestic poultry were in ducks, mainly ducks that are raised for foie gras production in France, which are raised in outdoor operations, and therefore they have more risk of becoming into contact with a domestic waterfowl. However, later in the season, the viruses probably became more adapted to gallinaceous species, so we had an increase in number of turkeys and chickens affected. And what happened this year? We have a mix of the outbreaks, both in waterfowl but also in gallinaceous species. And in fact, we have had a lot of outbreaks in turkeys, chickens, that have affected especially the countries that I'm listing here: France, Italy, Hungary, and Poland, in this order. So one of the questions that arises while looking at these graphs are if biosecurity measures are effective, because we know that these viruses are circulating in wild waterfowl, and we have measures in place to strengthen biosecurity in farms. And in fact, some farms that have high biosecurity standards, like breeder farms, they have also been affected. So the question is whether these biosecurity measures are being effective and whether they are being correctly applied. If we look at this, a similar graph, but taking into account the type of wild bird affected, we can see that both last year and this year, wild waterfowl like goose, ducks, swans, etc., they have been mostly affected, which these are the target species that we expect to find avian influenza viruses. And we know that these clade 2344 viruses, they can affect these birds. They can also cause clinical signs of mortality. We also have some raptors affected. And this is interesting because, as we demonstrated some years ago through an experimental infection, we saw that falcons, for example, they are very susceptible to infection, both with low and highly pathogenic avian influenza viruses. And we actually demonstrated that these birds, when they feed on infected carcasses or infected birds, they can become infected. So in the wild, we know that if we see raptors that are sick with neurological signs, or we find them dead, we know that they can act as sentinel species, and they can indicate that the virus is actually circulating in the waterfowl species. One interesting aspect that happened last summer is that avian influenza viruses, they were detected during summer months in waterfowl species, which indicates that not only migratory birds coming from Russia and Siberia, they are bringing the viruses to Europe, but resident birds in Europe, it seems that they are also being infected and maintaining these viruses in the continent. So this is something to watch out for this coming summer. And this would be the most updated map that we have of the outbreaks in Europe. As always, all the information is available publicly from the ECDC and the Istituto Zooprodilactico of Venice. And if you compare the number of outbreaks and the number of countries affected this year compared to the other two worst years that we had previously, we can see that the current episodic is the worst. And in fact, there are still outbreaks being declared in some countries. So let's see what happens in the summer months. As you can see, many wild bird detections have been happened in Central and Northern Europe. And we had clusters of domestic detections in northern Italy, in France, for the first time in Spain and also Portugal. So southern countries have also been affected this year. So this is for sure an evolving situation that we have to keep an eye on. And now what? So as I said, continues to circulate this virus in domestic and wild, not only migratory, but also resident birds in Europe. Therefore, we expect new incursions in domestic birds. We know that there's also circulation in Russia, Africa, and Asia, which is important because while migratory birds, they come from these areas. And so it's telling us that new introductions of new strains may be happening in the coming months. Now we are in spring, entering summer, so this goes in our favor because the virus persists infectious less easily in the environment because with the heat, the virus inactivates. And we also have to keep an eye on the ability of these viruses to infect mammals, because we have seen mammal detections in foxes and seals in Northern Europe that indicate that these viruses can actually infect mammals. And so we really have to survey the circulating viruses for mutations that indicate zoonotic potential. And I'm going to steal this summary from Badewes et al., indicating that until now, we knew that wild waterfowl were reservoirs for low-path viruses that could infect domestic poultry, and high-path could only arise from these domestic poultry. However, with the current situation with goose guangdong viruses, we know that wild waterfowl can also be infected with these high-path viruses. And not only that, that clade 2344 may be also being maintained in this wild waterfowl. So we could also consider that wild waterfowl may be the reservoirs for not only low-path viruses, but also highly pathogenic avian influenza viruses. And so with this increased risk of high-path in Europe, of course, we have to strengthen surveillance, biosecurity, and early detection methods, not only in in domestic waterfowl and outdoor raising poultry, but also intensive farming. We have also to strengthen surveillance in mammals and also poultry workers. Continue with the swiping out movement restrictions, etc., which have been the traditional method of controlling these outbreaks, but also and probably consider the implementation of vaccination, which of course it's a very hot debate right now. So with that, I would like to thank the sources that you can also find online, and thank you for the attention.
Thank you very much, Dr. Bertrand. First of all, let me share with all the participants that there has been some technical issues, but please do not worry. The presentations will be recorded and you can watch them on demand. So just let us know. Dr. Bertrand, I take back home that the reservoir are wild migrating birds, mainly waterfowl, and that the virus can mutate, and that biosecurity is one of the 3 steps to pay more attention to next to surveillance and early detection. So let's focus on biosecurity in the next presentation. I have introduced my colleague Eline. Eline, the floor is yours, and tell us everything about how to prevent and control avian influenza, please.
Thank you, Luc. Thank you, Kateri, for the clear presentation. I think it's really helpful for everyone. So now I will talk about the technical and the practical approach, how to prevent and control avian influenza. So like mentioned in the first part by Dr. Bertrand, avian influenza is one of the most important poultry diseases, and it can be easily introduced and spread on your farm if farm biosecurity is not optimal, if you don't have good farming practices, and if there is too much movement coming to your farm and on your farm. So let's start with farm biosecurity. The high transmission routes or the high risk transmission routes are entrance hygiene, so related to movement of people coming to your farm or even on the farm itself between different barns. Also, equipment hygiene is a really important one. Take care of your equipment. I will go more in detail later on in this presentation. And last but not least, one of the highest risk transmission routes is transport as well. Not an easy one, I know this, but we try to help and to provide some solutions over there as well. Before we start and go to the high risk transmission routes, I want to talk about cleaning and disinfection as well, because that should be the basis of everything. As we know that cleaning can remove more than 90% of the pathogens, microorganisms that are present in the barn. So this is one of the most important things before thinking on other topics as well. Some key parameters to choose the right cleaning and disinfection products to combat avian influenza on your farm. And it's quite important to know this, to choose the right product. So the type of surfaces to clean and disinfect, we need to make sure that the product is working on every type of surface, plastic, concrete, vertical, horizontal surfaces. Spectrum of activity, so we need a broad spectrum disinfectant, and we need to make sure that we have proven efficacy against avian influenza. The ease of use and handling, it should be easy to apply for the farmer, for the workers that do cleaning and disinfection. Safety is really important as well, safety for the environment, but also for the material, so compatibility to material. We don't want to have corrosion after cleaning and disinfection, and of course also for the animals and the users. The storage of the product should be easy to store the product, not too many requirements. And then the application, so there I mean use the correct concentration, respect the contact time that we mention on labels and technical data sheets, temperature, pH, it's all important to take into account by choosing the correct product. And of course, the efficacy. So it needs to have a good efficacy. You need to make sure that it works against avian influenza strains. So every country has a approved list or authorized products, biocides effective against avian influenza. And you should only use these authorized products if you want to have the best efficacy or the best result in the end. So how to properly clean and disinfect in the building itself? We always start with a dry cleaning, of course, to take out all the organic matter, so litter, manure, and everything before we start with the main cleaning. You can do cleaning of the drinking water lines as well. That's highly recommended at every sanitary stop. So do it before you start the foam cleaning of the building and the equipment inside, because otherwise the dirty water can recontaminate the barn itself. Pre-soak can be done. It's an option, but not necessarily needed when you use a good foaming, good quality product. Then you start at the top of the barn and you go downwards while you do the cleaning. So start at the ceiling, ventilation systems, heating systems, then feeding and drinking water lines at the outside, of course, and then going down to the walls and the floor. Then after the cleaning is done and we respected the contact time, you need to do a high pressure rinse with clean water. Let it dry before you go to the disinfection step. After the drying time, we can start the disinfection. So we recommend always a foam application because it has a longer contact time, a better attachment, and it's visual. You see what you do. And for sure, when you have a disease outbreak, it's really important that you cover everything to get rid of the pathogens. Then you leave it there to dry. And after it's dried and you prepare the barn, or even before you prepare the barn, that's up to you, you can do a thermal fogging where it's allowed. You always need to check your registration in your country on the biocides. And after fogging, we just leave it to dry before animals can enter the barn. So some tips and tricks that I want to share with you on cleaning and disinfection in the buildings or in the barns. Let's say you should always work with an all in all out system, and you should work on one farm, if possible, with the same age so that you don't mix ages of different animals. What do we need to clean and disinfect? I mentioned it in the protocol as well. In fact, you need to clean and disinfect everything that came in contact with the animals and that was used during the production cycle, if you want to be sure that everything is cleaned and disinfected well. So how to properly clean and disinfect drinking water systems? So you need to do it before the main cleaning of the building, otherwise you can have recontamination of the barn, the floor, or some equipment. you just add some product inside the drinking water system. You leave it there for the correct contact time. And again, respect contact time is really important to get the expected results in the end. So the product can be dosed with an automatic dosing pump. Then you open the tap at the end of the line to make sure that the correct concentration reaches the end of your drinking water line to have the best result, of course. Wait for it. So, for example, with one of our products, we have a contact time of 4 to 6 hours. And then after, you can empty the drinking water system and to rinse it and to have good results in the end. So mainly you will see dirt coming out of the drinking water lines. And that's the goal that we want to have, removal of biofilm that can be present in the drinking water lines. And an important thing there is touch the drinking nipples itself as well, that you clean the drinking nipples as well, and not only the tubes of the drinking water system. I mention this because avian influenza can be spread via the drinking water as well. So some tips and tricks, I think, and I mentioned many of them already in the protocol. So if you take water samples, do it on a regular basis to have the control of the drinking water status and to know if this is a problem, a priority on your farm or not. If you take drinking water samples, take them at the source and at the end of the drinking of the last drinking line or drinking nipple, because you need to know where the problem is located. Is it at a source or is it in your drinking water lines? Then, if we talk about transport hygiene, what is really important as well, and a high transmission route, a high risk, then we need to think about cleaning and disinfection of transport as well. I know in practice this is not so easy. I just want to share with you the most optimal protocol, and if we can take or make the best out of it, then it will reduce the infection pressure. So when a truck is coming on a farm, it should be disinfected, at least the wheels. So a wheel dip can be a good option, or you place or install a disinfection bowl to have a complete disinfection of the truck. Of course, when we talk about live animals, after we transported them, we should do a dry cleaning of the truck. Exactly the same principle as in a barn. Then we do the main cleaning with a foam detergent. We respect contact time before we start the rinsing with a high pressure machine and clean water. We let it dry. I know this step is often forgotten in the transport sector because there is not a lot of time, but we should take care of this. If you don't have the time to let it dry, make sure you remove the most water that is still inside the truck. And then we can start a disinfection. Again, foam application, and make sure you disinfect all parts of the truck. Next to the truck itself, it's important to keep the cabin of the truck clean as well. So we need to clean and disinfect on a regular basis the contact points or the critical points, like the stairs, the steering wheel, the pedals, and so on. And next to that, personal hygiene comes in place in this transport hygiene topic as well, because the truck drivers come on every farm and they go from farm to farm. So they should take care of hand hygiene, boot hygiene, and clothing hygiene as well. So some tips and tricks in the transport hygiene. So some good cleaning and disinfection practices. We should take care of all vehicles. So not only the truck of the live animals, not only the truck of the manure, not only the truck that comes from the hatchery, but also the vehicles that are used on the farm itself. And that's often forgotten because it's on their farm and they don't think about it. So all vehicles are important. Then all parts. So we need to take care of the wheels, the cabin, the equipment used on the trucks, but also wheel dips, spraying bows. We need to take care of them and make sure that they work properly. And then all conditions, I want to cover this as well because we need to clean it from top to bottom. And we also need to take or to keep in mind if we have cold temperatures, that we are sure that we can clean and disinfect our trucks as well. So place some buildings to put the trucks inside, some fans, heaters that we can dry the trucks. And if it's not possible, then we have some compatibility, chemical compatibility with viricid and propylene glycol. So this should not be a problem in freezing temperatures. Then some good movement practices, because movement is a high-risk transmission route as well if we talk about avian influenza. And here I want to focus on the word limited, because we need to limit people movement, animal movement, and in general, we need to limit the different sources coming to our farm. So limited people, I mean truck drivers, they should not enter the poultry barn. In practice, it's a difficult point, but we should keep this under control and make sure personal hygiene is kept in mind when they have to enter. Clean and dirty areas on the farm. So make sure there are hygiene logs that they need to pass and that they can follow the rules. And clear signs for access. So if people need to enter, if it's the owner, if it's an employee of the farm, or the vet or a technician, make clear signs that they know what to do and which requirements they need to go through before they can enter the barn. Limited movement of animals. We should make sure that there is no introduction of any animal inside our barn, because that's a high risk. So place grids, make fans that wild birds cannot enter your farm, because as mentioned by Dr. Bertrand, this is a high-risk vector, and they are the reservoir of the disease. Limited sources, so make sure you have the same supplier of your animals with a validated health status. Empty trucks, so the trucks should be empty when they come on your farm, otherwise it's a really high risk. And the fewer the deliveries, the lower the risk will be for introduction and spread of diseases. So here something about material and equipment, because it's also a high-risk transmission route. We need to clean and disinfect it on a regular basis as well, for sure at every sanitary stop, and even for some materials or tools, even more often, like the dead bins. I take this as an example here on the slide. We need to clean it, in fact, after every use. In practice, it's often not done like that, but that's the most optimal. And if you want to improve your hygiene level, and if you want to avoid having infections, you should clean and disinfect it every time it's used. So the same principle as in transport and building hygiene: dry cleaning first, then a main foam cleaning, a rinsing with high pressure and clean water, a drying time, and then we can disinfect and leave it there to dry. Some tips and tricks in equipment, so that's more related to farm management. It's a tricky one, if I need to be honest. We really need farm-specific equipment. So here I want to focus on the word specific. If we work with farm-specific material, barn-specific material, then we can reduce the risk of having introduction of diseases or spread of diseases on the farm. So take the right measures, take the right equipment on your farm, and avoid having external equipment or equipment from a neighbor or someone that you know. You need to make sure that this is controlled very well. And if you need to have external material, make sure you have a proper cleaning and disinfection protocol before you bring it inside the farm. Barn-specific equipment is really important if you have a farm with many barns on one location. Make sure, for example, a bucket or some other material like shovels or brushes, that they are barn-specific. You can use, for example, color codes to make it clear that the red color cannot go to the barn where you have also green colored equipment. And make sure this is cleaned and disinfected after every cycle as well. If you need to use materials in different barns, clean and disinfect in between. So you also need to have specific cleaning and disinfection protocols for all these equipments to make sure that they don't forget it, and the right conditions. So if it's not easy to clean and disinfect, you really need to dismantle equipment and do a manual cleaning and disinfection if necessary. Then entrance hygiene. So that's personal hygiene, hand hygiene, boot hygiene, clothing hygiene are the three important parts when we talk about personal hygiene. So hand hygiene, I hope and I think with COVID, everyone knows how to wash and disinfect their hands. In practice, you often see mistakes. So we think it's easy, but in fact, it's not that easy as we think. And often we do it too fast and we will not have a good result. Boot hygiene, the other one that is really important, because if you have some wild birds in the environment of the outside of your barn and they leave some droppings on the pathway to the farm and you walk through it, then boot hygiene becomes really important because that's one of the highest risks as well to bring it inside your farm. The most optimal protocol, if you have a lot of dirt on your boots, clean them first or rinse them first with water before you go through the disinfection bath. I really want to focus or stress out that you need to have a good management of boot baths. If it's not managed properly, it can become a contamination bath. So make sure you clean and disinfect your boot bath as well. You renew the disinfection solution on a regular basis. You check concentrations to be sure that it's still working well. I want to share a study that is done on some biosecurity errors in the poultry industry. So they checked the entrance hygiene and visitors coming on a farm and what they do and which kind of mistakes they make. And on average, there are 4 errors or mistakes made per visit in a poultry barn. So here I just want to show you, we think it's really easy because washing hands, we think we know. Going through a boot bath, okay, not that difficult, but if it's not managed well, we can have a lot of mistakes and high risks of introduction and spread of diseases. In one visit, they saw that the maximum amount of errors made by one person was 14 mistakes, just in the entrance. So you can imagine this is a really high risk. So they observed people on several visits and they made an average 6 errors per visit. So here a summary table with the main mistakes that were made. So the most common one is clean versus dirty zones. So there are no clear rules. They don't have physical barriers. People don't know what to do, so they walk around in the hygiene lock without thinking about clean and dirty zones. But you also see that boot hygiene, washing hands, and coveralls are in this list. So even the easy things are often underestimated, let's say. This is a table that comes out of the study. So you see the source in the bottom of the slide if you are interested in the study. And I think it's a really nice one to stress out the importance of biosecurity measures at the entrance of the farm. So here, the one with the highest percentage or the highest number of mistakes is washing hands. So it looks really easy and we all think it's really easy, but it's something that we really need to stress out because many mistakes are made against hand hygiene, almost 80% of all the visits. So then some examples of the delimitation effect in a hygiene lock. So I mean the physical barrier that is placed between clean and dirty zones, because we saw in the previous table that this was a common mistake. There we see, even if we put a bench or a door or a red line or a food bath, that people keep on making mistakes. So even when we try to make it easy for them and clear that they need to take an action, they make mistakes. So here I really want to stress out that you need to make clear rules. So good entrance practices with clear visual instructions, with clear equipment, with a clear process and a clear guidance for everyone. And everyone is really important because it's the owner, the farmer himself, the family of the farm, employees of the farm, the veterinarian technicians. Every person that enters the farm needs to be seen as a visitor and needs to follow the rules. So here in the photos, I just want to show if you have hand washing facilities, but there are syringes and needles and other tools inside, then you cannot expect people washing their hands over there. The same for showers. If there is a shower installed, but there is only cold water, then we cannot expect people to take a shower. So make sure you have the proper equipment that you can make the requirements in practice, that you can put them in practice. So our solutions or our avian influenza program looks a little bit like here on the picture of this on the slide. So we focus on the different transmission routes. So you see entrance hygiene, boot hygiene, hand hygiene, really important to take care of. Then transport hygiene, cleaning and disinfection of all transport, all parts of the vehicles. Also personal hygiene is an important one over there. Barn hygiene, general cleaning and disinfection. And in barn hygiene, we have, of course, water treatment and water system cleaning and disinfection as well. So then I can go to the conclusion. I have some take-home messages. In many studies, research, and literature, they saw that outbreaks were reported due to biosecurity shortcomings. So it's proven that we often make mistakes or that we have poor biosecurity. And that's where we want to help and to give you the right solutions and protocols to improve biosecurity and to avoid these shortcomings and outbreaks, of course. So I focused on 4 keywords and I would like to take them home, let's say. The first one is all. So we need to take care of all vehicles, of all persons coming on the farm, but also on all transmission routes that you see in the picture. It's not only cleaning and disinfection. It's not only water treatment. It's not only personal hygiene. We need to take care of all the different transmission routes. Then the second one is clear. I focused on clear when I was talking about entrance hygiene. Make clear instructions, clear visual instructions. Make sure that everyone knows what to do, even if they don't speak the language. That's why you should make them visual, that everyone can do what you want them to do. Then the third one is specific. I related it to material because I think it's the most important one over there. Farm-specific material, barn-specific material, and specific cleaning and disinfection protocols for everything in the barn. And then the last one, limited. I related to transport, but in general, I related to movement. Limited movement on your farm related to visitors, people coming on your farm, but also trucks, transport, deliveries, supply. If you can reduce them as much as possible, it will lower the risk of introduction and spread of diseases as well. So that are my take-home messages. I hope you agree with them. I want to thank you for your attention and for listening to us. And I give now the floor back to Luc. Thank you.
Thank you very much, Eileen. Thank you for your very practical tips and tricks and your take-home message. We will never forget them, I promise you. I can wrap it up as saying a chain is as strong as its weakest link. So attention to detail is very important. I also would like to summarize what Dr. Bertrand said about the reservoir. In my opinion, the reservoir of wild birds migrating for a poultry producer are part of our circle of interest, meaning there's nothing a poultry producer can do about contaminated birds flying around the globe. However, Eline, you told us that 90% of the transmission is caused by vectors that I would classify as being part of our circle of influence, meaning it are all vectors that we can control, we can be proactive and prevent. Also, I would like to mention before we start with questions in the chat box that Sidlines and Ecolab company will issue a certificate of participation, and there will be slides that will be shared, and we will equally share the name of the paper that was mentioned in Eline, her presentation. And before going to the chat box, I would like to ask to Dr. Bertrand a question or a confirmation. Dr. Bertrand, you said that raptors and mammals can get the disease by eating carcasses, raw carcasses of dead birds. I have read, and please confirm if it's true, that at 77 degrees centigrade, the avian influenza virus dies within 1 second. So is it safe to conclude and say that both poultry meat and table eggs are safe as long as they have been cooked?
That is correct. Influenza viruses are very liable, so high temperatures are going to inactivate them. And so if you cook fully meat and eggs, that's safe. However, in our context, which is the European Union, and I know that the US and other countries, any infected farm doesn't go to food consumption, just to eradicate any option of spreading the virus. But yes, cooking is safe.
Right, and that is what I would call the macroeconomical importance of avian influenza. And as you touched on the topic, Dr. Bertrand, can you maybe share in Europe, are governments compensating to farmers if they have to kill their birds?
As far as I know, and this is not my specialization, but as far as I know, the European Union member states, they are compensated for avian influenza outbreaks. So anytime that a farmer or a producer declares an outbreak, there's compensation for both culling and cleaning and disinfecting, and also, as far as I know, economic compensation for any economic losses for those birds that were not sold.
Right. Thank you, Dr. Bertrand. I have one more question here in the chat box for you. Is avian influenza an airborne disease, and how many meters can the virus fly or spread through the air?
Yes, so avian influenza and influenza viruses in general, they are airborne viruses. So if you think of human seasonal influenza viruses, of course, they are spread through aerosols, which now that we have heard of COVID, they are these smaller particles of air where viruses can travel. They can travel very far distances for many meters. And they can also be transmitted through droplets, which is a little bit bigger air particles that cannot travel as far, but they can also help with the transmission. So yes, they are airborne. And in fact, if we have a barn with thousands or hundreds of infected birds, that air is full of infectious viruses.
And I think since COVID, we all know what aerosols are. I have one more question for you, Dr. Bertrand. After an AI outbreak, how many days should the shed be kept empty?
I don't know if that depends on the country, but at least in Spain, when an outbreak is declared and birds are culled, after cleaning and disinfection, there have to be a period of 3 months before any new birds can be introduced in the barn. And within those 3 months, it also includes a period in which some sentinel birds are introduced in the farm for 3 weeks. and then they are tested for avian influenza to confirm that they are actually negative. So more or less, the whole process would take around 3 months.
Thank you, Dr. Bertrand. One more question for you, I think. What about vaccination? Can you expand a little bit on the topic of vaccination against AI?
Yeah, that's always a controversial issue, especially nowadays. Historically, the European Union has banned vaccination for commercial birds. So it's available for particular species like in zoos or for raptors. But for consumption, it has always only been accepted in very particular instances. For example, the outbreak of 1999 in Italy of H7N1, the vaccination was allowed under very particular circumstances, defining very well what was the scope, what was the region, what type of birds, etc. Right now, I know that there's been discussions about whether to vaccinate birds preventively before the season of avian influenza starts in the fall, or once the first outbreaks happen in poultry farms as a tool to help with the control of the dissemination from farm to farm. So far, it's not approved, but I know that there's some trials ongoing. Like, for instance, in France, they're already trying vaccines in ducks. And I'm pretty sure that other countries like the Netherlands are also with ongoing studies. But of course, there's another whole set of problems related to stakeholders, industries wanting to invest in these types of vaccines and taking into account what would that happen with the export of poultry and poultry products to third countries.
Right. Thank you very much, Dr. Bertrand. I read a question that is for Eline. Have your products been tested by independent institute on the AI virus? And if yes, by whom and against which serotypes? Eline?
So yes, we have 3 different strains tested by independent organizations. So the H5N1 that was tested in the reference lab for avian influenza and Newcastle disease. Then the H5N8 that was tested at the University of Wageningen. And then the H9N2 that was tested at Microbiotest in the USA. So there, it's a nice one because we have 5% of organic load that is included in the test report, let's say. So yes, we have.
So indeed, important to stress that American standards require a higher organic load during the testing protocol. Indeed, thank you for that. And then I have a question here also for you, Eline. Must probably come from a cold country. How do you disinfect a truck when it's freezing outside?
So the most optimal thing is, of course, that you have a building and to do a cleaning and disinfection of the trucks inside, and that you have heaters and so on to avoid freezing temperatures during cleaning and disinfection. But if this is not the case and they have to do it outside during freezing period, then we have a compatibility of our broad spectrum disinfectant Virus-It with an antifreeze propylene glycol.
Right. Thank you, Eline. We have another question here for Dr. Bertrand, coming back on vaccination. Dr. Bertrand, you mentioned that the viruses mutate easily. So the question here I read is vaccination a silver bullet to an AI outbreak, or do you need additional measures to support it?
I'm glad that there's this question because sometimes we think that vaccination indeed is the silver bullet, and it's not. It has to be complemented with all the other tools that we have, especially biosecurity, early detection, surveillance, all these other measures that we normally take. And so vaccination, even if we have the best vaccine in the world and that matches perfectly with the circulating viruses, if we only apply vaccination with any of the other measures, we're not going to be successful.
I kind of agree to that. And another question was coming in the meantime. What is the proper age of the bird to vaccinate?
So it depends on the vaccination program. Right now, those countries that vaccinate, they have seen that the most effective program would be to vaccinate with a recombinant vaccine in the hatchery or at 1 day of age, and then to boost at 3 weeks or 2 weeks with an inactivated vaccine. And in the case of longer-lived birds, like layers or breeders, then they would be boosted with additional inactivated vaccine after certain months, depending on the lifespan. That has been shown to have the best protection, because recombinant vaccines, they boost both cellular and humoral response, and they are typically not inactivated by maternal antibodies. And then inactivated vaccines, they reinforce that humoral response with antibody production.
Great. Then I have one more question I see, probably for Eileen. What is the importance of disinfecting both the water lines and the drinking water itself?
So the drinking water lines, of course, because avian influenza can be spread via the drinking water, so it can contaminate your drinking water system. There we need to clean and disinfect at sanitary stop. So when the barn is empty, to remove biofilm, to take out all the deposits that are inside the line, organic, inorganic, and to really disinfect, so to eliminate pathogens inside the drinking water lines. And then, of course, drinking water disinfection can be done during the production cycle, depending on the registration, of course, of the biocides that you have. So it needs to have the claim drinking water disinfection. And then you can disinfect the drinking water itself. If it's contaminated with the virus, then you make sure it's not getting at the level of the birds.
Right. Thank you. Eileen, another question for you, and I think, based on my experience, that this is coming from North America. What about the quicklime food bath, which is the powder in a food bath?
Good question. So we like more liquid products, because we are sure they are dissolving 100%. So you have a nice mixed solution. With powder, you have to be careful that it's well mixed and that it's well dissolved to have the efficacy that they guarantee you.
Thank you. And you would probably agree that for a good food bath management, the same rule applies: first cleaning, then disinfection. So you really need to scrub off the organic dirt from the boots before you plunge them in your food dip.
Yeah,
in order to have a disinfection bath instead of an infection bath, kind of an organic soup. Right?
Indeed. Remember the slide where I mentioned with the cleaning step, we can remove more than 90% of the microbes. So that's in every application, in every transmission route, cleaning stays the most important step. After an efficient cleaning, you can go for an efficient and a sufficient or a fantastic disinfection, but not without a good cleaning before.
Then a question for Dr. Bertan again. How do you see next autumn or next winter about avian influenza in Europe?
I wish I knew, but
crystal ball?
I don't have a crystal ball, but based on one of the last slides that I presented, which is the continuous circulation of viruses in other parts of the globe where migratory birds come into Europe from, like Russia, Africa, Asia, those viruses are still there. And that tells us that in the fall we have to expect new incursions of new viruses. We don't know if that's why we need to survey these wild birds in other locations to pretty much know what's the variety of viruses that we're expected to get into the continent and be better prepared. But we'll see if summer months, during the summer months, we still have detection in wild birds, which, as I said last year, that indicated that resident birds are maintaining those viruses here. And in addition, we will have probably new incursions in the fall.
Thank you. Then there is a question. I see that is directed, I think, to me. What is the best disinfectant you will recommend? Of course, I have been in sales. I would say Virusid because we have these tests. But joking apart, I think to be non-commercial, there are a number of criteria you should tick off when you talk about the criteria to select a disinfectant. The first one is safety. At Ecolab, safety is our number one value. And when I say safety, I mean safety for the people, meaning being non-carcinogenic, such as formaldehyde, which equally makes it safe for the birds, for the animals. Also safety for the equipment, meaning being non-corrosive, meaning having a neutral pH and eventually having some testing data on corrosion. And thirdly, safety for the environment. In Europe, the highest level of biosecurity requirements have to be met over here. And then, of course, proven efficacy, as Eileen has already explained, and ease of application. In my opinion, a disinfectant should be able to be sprayed, evidently, but also to be foamed. And the advantage of foaming a disinfectant is that you can visually check if every square centimeter or every square inch for the audience from North America has been covered. It's a visual control, and foaming allows for a longer contact time on vertical surfaces, on round tubes as feeders, on ceilings, etc. And the third one is fogging, aerosol production or aerial disinfection. So I think these are important criteria to check for the selection of a disinfectant. I get another question here. Is there any disinfectant for litter material treatment and dosages? I will turn that question to Eileen.
So you can, like I mentioned a little bit in the general cleaning and disinfection protocol, you can do thermal fogging when the barn is prepared where allowed. So you need to check with your registration in your country, because this differs depending on the biocidal registration, of course. But if you have it in the registration, you can do, yes.
Another question for you, Eileen. Do you recommend to change clothing always, as well as besides stepping into a food bath before entering the stable? Do we need house-specific clothing as well?
Of course, the most optimal is to change in every house clothing and shoes or boots, because it's possible if they have 5 houses on one farm and they have the disease in one of the 5 houses, then you should change shoes, boots, clothing to go to the other one to avoid the spread of the disease or other pathogens as well. In fact, you don't need an avian influenza outbreak to take these measures. I would say for salmonella or some other pathogens as well. It's good to change or to have barn-specific shoes and clothing for every individual barn.
So an ounce of prevention really is worth a pound of cure.
Yes.
And with that question on clothing, ladies and gentlemen, we're getting near the closing. Unfortunately, time flies in good company. I would like to thank everybody who has been putting questions in the chat box. And again, I want to stress, if there are more questions, feel free to send them to us. We will follow up on them. You will get an answer on your question, and you will get also more information as a summary of this webinar. A special thank you, Dr. Bertrand. Thank you, Eileen. Thank you, everybody from around the globe, and looking forward to our next interactive seminar.